So these equations here would be a little bit more typical of what you would be solving for. Okay, so these are, again, there are multiple steps here, but we do have to make sure that we are keeping track of things. Here we're going to state our restrictions with inside and outside restrictions because this is a single square root equation, so this is much easier to state an inside and outside restriction. Okay, so our domain is from the inside is going to be x is greater than or equal to -10. From the outside, the domain is going to be here. Okay, the square root must equal positive, so x must be greater than or equal to -4. Okay, so putting these two domains together, it has to be bigger than -4 and bigger than -10, which means that x is greater than or equal to -4. Okay, so we go ahead and solve this. So we need to undo our square. Sorry, we need to undo our square root. Remember to FOIL this out. We need to expand that properly. So here we end up with x plus 10. Here we end up with 16 plus 8x plus x squared. It's a quadratic, so we make it equal to 0. We end up with minus 10 from both sides. I'll write it this way, x squared. We're going to minus 1x from both sides. We're going to minus 10 from both sides. Okay, this is a factorable quadratic. We get plus 6 plus 1. Okay, so we end up with x equals -6 and x equals -1. Based on our domain restriction, we can probably see that x equals -6 is probably going to be extraneous, but we should test it. Okay, testing is the easiest and most straightforward way of determining extraneous roots. So we're going to test x equals -6. When we plug it in, we end up with 4 is equal to 4 minus 6 is -2. That's not true. This is extraneous. Okay, then we test x equals -1. When we test x equals -1, I end up with x square root of 9 is equal to 4 plus -1 is 3. That's okay, so this is a good solution. Okay, so that's non-extraneous. For this one here, we can set our equation, we can solve the first step of this equation, so we can isolate our square root. So we end up with 22 minus 2x is equal to x plus 1. We can set our inside domain restriction. Okay, so x must be 11 or smaller, because if it's bigger than 11, we're going to end up with negative inside the square root. So x must be smaller than or equal to positive 11. Okay, 10 would work. Okay, and the outside restriction, so the square root cannot equal a negative, so x must be greater than or equal to -1. Okay, so here our domain restriction together looks like this. It's in between -1 and 11. We'll go ahead and solve this algebraically. Undo the square root. Okay, and then make it equal to 0. We end up with x squared plus 4x. 20 minus 22 from both sides, we get minus 21. So we're looking for two numbers that multiply to 21 and have a difference of 4. Yeah, that is factorable. So it's going to be 7 times -3. We get a solution of x equals -7 and x equals +3. So it looks like based on our domain restriction, -7 doesn't fit our domain restriction. Okay, so that's going to be our extraneous solution. Okay, so when we test our x equals -7, we're going to end up with a square root. That's going to be 36 minus 1 is equal to -7. Well, that's not true. That doesn't work. Okay, extraneous. Okay, we'll test x equals 3. So we end up with square root 16 minus 1 equals 3. So 4 minus 1 equals 3. Yeah, that's perfectly good. That is the valid solution. And again, we can check this by graphing as well. If we graph this, we'll see the extraneous solution doesn't show up, and we'll see our real solution showing up.